Good afternoon. Good afternoon. Hope all is well and everything's all right. All right. So let me see. Is everybody in? Looks like it. So I was in the process of looking at some stuff out of 5.3, and I noticed there was some things that they were asking and expecting of you in 5.3 that they hadn't talked about. So I missed a problem or two or something. But normally this section is like a whole section and not just a couple like a problem. All I saw was like a problem but it's something that we really need to emphasize. So we're going to talk about this today. It's actually at the tail end of 5.2, but you need it in order to do 5.3. And we're talking about the applications of normal distribution. Also, if my audio sounds choppy at any point, let me know. I was having some issues. Well, there was an outage in my Wi-Fi. I know my last class, I was in and out volume wise. So let me know because I can't use that recording. So hopefully I'll be able to use this recording. So let me know if I go in and out on the volume. Okay. As a matter of fact, let me see. All right, so we already talked about converting to z-scores. Did that last class. So it's just a reiteration of what we talked about last class. Your data value minus the mean divided by the standard deviation. And you're going to need the chart, and it's on pages 370 to 371, and it's called Table A-1 in your appendix. And I'll show you the chart, pull it up, show you how to use it and everything. All right, can I scroll up? All right, so remember I mentioned also that our z-scores, we're always going to round to 2 decimal places. That's because we need those 2 decimal places for this chart that we're about to look at. And let's say if we have the z-score of 1.23. Everybody hold on to that red statement. All right. So let's say if we have that z-score of 1.23. Everything that precedes the last digit will be over here on this left column. So the 1.2, and then that last digit, which is the 3, will be up top. So whatever that last digit is will be on the top. Everything, the last digit will be on the left column. So we found the 1.2 over here, 2 with the 3 up here, and where they meet at chart value that we pull. And of course, we'll talk about what a chart value means, in a second, but we're just talking about reading the chart, how we're going to read the chart. Once again, the rightmost digit will be up top here, and everything that's before that rightmost digit will be over here on the left. All right, so let me show you what this chart looks like. All right, so it looks similar to this. It'll be 2 pages. One page are your negative values. If your z-score ended up being negative, it'll be on this page. If your z-score ended up being positive, it will be on this page. But it's one whole chart. It's just that it's, the data values, have a lot of stuff going on. So they have a negative page to the chart and a positive page to the chart. All right. So 1.2 is right here. 3 is right here. And then where they meet up is a value that we pull from the chart. So that's 0.8907. All right, questions on what I just did there? All right, so let's see. 1.2 is right here. 3 is right here. And then where they meet up is a value that we pull from the chart. So that's 0.8907. All right, questions on what I just did there? 1.2 is right here. 3 is right here. And then where they meet up is a value that we pull from the chart. So that's 0.8907. All right, questions on what I just did there? So let's say if I had something like negative 0.15. So I'll go to the negative side, which is this. Negative 0.1 is right here. 5 is right here. And where they match, that's where I'll pull my values. So there's something in chart. You said, can I upload it upline? Are you asking me, can I, or are you able to? Let me make sure I answer your question correctly. Yeah, I'll send it to you guys. I can send it to you guys. Yep. All right, so questions on reading the chart and how to do that. Yep, no problem. All right, so let's go back to the notes. So 0.8907 is what we pulled from the chart. Of course, MATLAB will let you know if they want 3 decimal places or the full 4. And so notice this box right here. It says the chart value will always represent what is to the left of the data value, or in other words, less than. And that is most definitely going to matter as we get to our applications. But let me show you this real quick, and we'll come back to the notes. Notice in the diagram right here, it shows you shaded to the left. And then here, same thing, shading to the left. So it's just letting you know that every value you pull from this chart, out of this chart, represents what's to the left, the percentage of information or data, whatever you're dealing with, to the left of your data value. And to the left will always represent less than. All right, scrolling up. And then to find out what is to the right of the data value, you will subtract that chart value from 1. So everything under this curve is equal to 1. You remember we talked about your mean being in the middle, 50% of your data being to the left, 50 of it being to the right, 50 and 50 added to give you 1. So if you want to know what's to the right of your data value, you just subtract that chart value from 1. All right, can I scroll up? Anybody hold on to green? All right, so we have a pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with mean 38.72 inches and standard deviation 3.17 inches. Determine the proportion of the 3-year-old females that have a height less than 35 inches. So it told us that it was approximately distributed. And our reason why that's key is because that allows us to use these scores in your normal distribution. It has to be normally distributed. And that's the bell-shaped curve. All right. So first of all, start off with the given information right here. 38.72 is our mean, 3.17 is our standard deviation, and our data value is 35. And then from there, plug it into your z-score formula. 35 minus 38.72 divided by 3.17, and that'll give you negative 1.17. So before we go any further, make sure you're okay. All right, scrolling up. So then once you have your z-score, you go to the chart. And the rightmost digit, which is a 7, that'll be on top. Negative 1.1 will be to the left. And they meet up at 1210, 0.1210. Letter under the M. Are you talking about this as your M? Okay, that's Greek letter mu. This is mu, and this is sigma. Yep, so. Yep, no problem, no problem. Make sure we're all good before I scroll up. All right, so we convert to the z-score, the 35 to a z-score, which is negative 1.17. And then go to the chart, we get 0.1210. So here we're just re-emphasizing what happens with the chart. The chart always gives less than. And remember, less than is what we were looking for. So we're just going to use the chart value. So the proportion of the pediatricians, 3-year-old females who are less than 35 inches tall is going to be 0.1210. And if MathLab tells you they want it as a percentage, then you just move your decimal 2 places to the right, which would be 12.1%. All right, now scroll up. Okay. All right, so using information from the previous problem, we'll find the probability that a randomly selected 3-year-old girl is taller than 37 inches. All right, so we already established that our mean is 38.72, standard deviation is 3.17. And then our data value is 37. So we have z-score negative 0.54. The 4 will be on top, in that top row. The negative 0.5 will be on the left column. And that gives us a chart value of 0.2946. So the chart always gives less than. We already talked about that. So to find greater than, we want to subtract the chart value from 1. So we want to find taller than, we do 1 minus 0.2946, which is 0.7054. All right, let's scroll up. So this is the last different type of scenario that you would see. So we had less than, greater than, and now we have between. So we're still using the same information. Found a probability of randomly selecting a 3-year-old girl that is between 35 and 40 inches tall. So now we have 2 data values that we have to consider. We get that a little better, 35 and 40. So we need to convert both of them to z-scores. All right, so for the first one, get negative 1.17. Second one, 0.04. And taking both of them to z-scores, not z-scores, taking z-scores to the chart, get 0.1210, 0.6554. All right, let's go look. All right. So this is just a diagram just showing you what a visualization of what actually happening and why we're subtracting. So, Z1 is right here to the left. This is to the left of Z2. So if I wanted to get what's in between them, I would just subtract this part over here. That's what we're doing, subtracting the two chart values. So be careful here, we're subtracting the chart values, not Z-scores. And you subtract the greater one first, the smallest one from the greater one in order to get your value. We got 0.5344. Are we good? Questions? So this is just a summary of the three scenarios. You only have three scenarios that you could come across. And you'll have key phrases that will dictate which one you do. But less than, you can hear, see the word shorter, colder, below, under. It depends on the application and what is going on in that word problem. But that is going to prompt you to just use the chart value that you pull with your Z-score. Greater than could give you taller, hotter, above, something along those lines. But if that's the case, then you're going to subtract your chart value from 1. And then I couldn't think of another word for between other than just between. And then from there, you would subtract the two chart values from each other. And once again, the larger one first, then your smaller one, your area or your percentage should never be negative. All right, can I scroll up? All right, we'll do one more example, just re-emphasizing the process. So based on the data from the College Board, SAT scores on the math level 1 are normally distributed with a mean of 621 and standard deviation of 96. So once again, they mentioned being normally distributed. If it's normally distributed, that means we can use the Z-scores on the Z-score chart. And so the first one is find the percentage of scores that are greater than 600. All right, just looking for something in the book. But yeah, so our mean is 621. Standard deviation is 96. And the data value in question, talking about being greater than 600, is X. So when it comes to Z-score, that's 600 minus 621 divided by 96. And notice it gives us negative 2.1875, but we need to round to 2 decimal places. So it's negative 0.22. Mhm. So go to your z-score chart. 0.02 is up top, negative 0.2 on the left. That'll give us 0.4129. So we want greater than. Remember, the chart always gives us less than. So if we want greater than, we do 1 minus the 0.4129. And that gives us 0.5871. And they said in this problem that they want a percentage. So that move the decimal 2 places to the right, that'll be 58.71%. All right. Problems, we'll go to the next one. So you got a chance to copy without moving forward. All right, so find a percentage of scores less than 700. So this time we're looking for less than 700 with a mean 621, standard deviation 96, and our data value 700. Mm-hmm. So convert it to a z-score. 700 minus 621 divided by 96 will be 0.82292. Round to 2 decimal places is 0.82. And so 0.8 will be on the left column. That should be 0.02. So 0.02 will be up top. That'll give you 0.7939. Hold on, so let me see. Did I put a 0 up here? Yeah, I did. Okay. And less than, which is what we were looking for, means that we would use the chart value. So 79.39%. Questions? Any questions? Make sure you're okay. All right, last one. So we want to find percentage of scores between 550 and 650. So we have two different data values. So I'll call it X1, X2. Mean is still 621, standard deviation still 96. We have 550 and 650 that we need to convert into z-scores separately. So the first one, 550 minus 621 divided by 96 is negative 0.7396, negative 0.74. And then 650 minus 621 divided by 96, 0.3021, which would be 0.30. So take negative 0.74 to the chart, get their chart value, which is 0.2296, and then take 0.30 to the chart, we get 0.6179. And since we're looking for between, we're going to subtract those two values. 0.6179 minus 0.2296. And that'll give us 0.3883. Questions, anything, anybody? Everybody good? Everybody straight? No questions? I think that was the last one. Yep. So it's important that you try these things out. Make sure you're good with it. Make sure you don't have any questions or issues. My last class, we got clipped right here because of my Wi-Fi stuff and everything. So, but it's a good place to stop. I think it's a lot of information and give you enough for you guys to chew on. Next class, we'll do 5-3. We may do 6-1, but it's probability. So I may save it for next week and start fresh. Haven't decided yet, but I know we're gonna, knock out 5-3. But try to stuff out. See if you get stuck. Remember, every day is an opportunity for questions. See if you have, if you have them, and we'll go from there. Any questions, concerns, comments before we close out today? Oh, what I'm going to do right now, I didn't get a chance to make those videos for you guys. Hopefully this one turned out okay. And then I'll send this with those other two from last week. All right. So I do have one of your classmates that have a question. If you want to stay back, hold on. Are they class questions or personal questions? I don't want to invite people to your personal questions if you had personal stuff to deal with. Okay. Yeah. So any questions before I close out? Any work questions? Everybody good? Straight? All right. So if you guys are good, I'm good. Have a great day, and I will see you on Wednesday.